Hello everyone. Today we are going to present our project towards point cloud rotation invariance using point pair features. Point cloud is a set of data points that represents the 3D shape of an object. There are lots of research that works on classifying 3D point cloud, but after we rotate the point cloud, the network is easy to misclassify the object. Lots of networks are not rotational robust. Meanwhile, in the literature, there is a 3D featureization called point pair feature, and it is completely rotational invariant. So we want to incorporate this featureization in point cloud classification to improve rotational robustness. Recently, there's a paper that studies different properties of point cloud network on ModelNet 40. It shows that most models are not robust to test-time rotational perturbation, and some specifically designed models achieve rotational invariance at a cost of overall performance. Here, let me introduce the point pair feature. For a point cloud, PPF takes 2 points. Suppose x1 and x2 are spatial coordinates, and n1 and n2 are surface normal vectors. It calculates 4 different values. First is the Euclidean distance between two vectors. Next, it calculates 3 angles among surface normals and distance vector. Those are between n1 and d, between n2 and d, between n1 and n2. These 4 values form the PPF of 2 points. You can easily see that after we rotate or translate the point cloud, these 4 values don't change, so PPF is invariant to rigid transformation. Next, our idea is to incorporate PPF to existing models. Here is a pipeline of PointNet. It takes spatial coordinates xyz as input, and we want to change this into PPFs. So we first sample a reference point in the point cloud. Then we calculate the PPF of every point in the point cloud with respect to this reference point. And we use this as input featureization, replacing the original xyz coordinates. For choosing the reference point, we tried a randomly sampled point, a center point of the point cloud, and the farthest point from the center. We also designed another way of PPF featureization in PointNet++. In set abstraction layers, it first samples some anchors, finds their k-nearest neighbors, and form a small point cloud. Then it runs a small point net on each of them. We propose that within each small point cloud, use the anchor as the reference point, calculate PPF for the rest points, and stack them together as the input. Here we called the sampling strategy PPF anchor. These are the results for different sampling strategies. For PointNet and DJCNN, we tried the vanilla network with and without surface normal vectors. We also tried center, random, and farthest PPF sampling strategies for reference point. We can see that the vanilla models overfit the training set and don't generalize to rotated point cloud, and PPF significantly increases the validation accuracy, and using center reference point performs the best. This is the result for PointNet++ compared to vanilla PointNet++ using PPFs with center reference point or anchor reference point shows better results. We also explored the influence of training data augmentation. We tested on 4 different combinations, with or without PPF, with or without test-time rotation perturbation. These are the results for PointNet and DJCNN. We can say that when we use training augmentation, PPF harms the performance. We hypothesize that it is because we sample a single reference point for the whole point cloud, and training data augmentation will constantly change the reference point, which confuses the network learning. We tried similarly for PointNet++, except that we use PPF anchor rather than PPF center sampling strategy. We can see that applying PPF's anchor improves the performance on rotated validation set. We think that in PointNet++, PPF featureization in local region leads to better test-time rotational robustness than just taking difference of spatial coordinates. In conclusion, we found that PPF featureization can improve rotational robustness when training with no augmentation. Sampling a single reference point globally does not work when training with augmentation. Using anchor point as reference point improves the rotational robustness in PointNet++. For future directions, we plan to incorporate PPF hierarchically into PointNet++ and test whether PPFs are robust to other point cloud perturbations. This is for our presentation. Thank you for listening.